Well, dear student, now again I am going to solve some question for you on interference of light. Here first question is there. The central fringe of interference pattern produced by light of wavelength 6000 angstrom shifted. You please, I am requesting you to please note the question when you are watching the video. The central bright fringe of interference pattern produced by light of wavelength 6000 angstrom is shifted to the position of fifth bright fringe. Position of fifth bright fringe. When glass slab of thickness of reference 1.5 introduced in the path of one of the interfering beam, the thickness of the plate. So I have told you, actually question is that here the two slits are there and central bright fringe obtained here gets shifted when we place glass slab. This gets shifted to fifth bright position. The central bright fringe when lambda 6000 angstrom is used, it gets shifted to position of fifth bright fringe. So what is the thickness? N of this is 1.5. What is thickness? T. So I told you that thickness shifting of the central bright fringe will be n minus 1 into T into d upon small d. This was the shifting of, and the shift takes place here to position of fifth bright fringe without, when we obtain fifth bright fringe without slab, that you know x5 is equal to xn. You know xn is position of n bright fringe, n lambda d upon d. Here n is equal to 5. So this x is equal to x5. So 5 into lambda d upon d is equal to n minus 1 into t d upon d. These d cancel. 5 lambda 6000 angstrom 10 to the power minus 7 and 1.5 minus 1 into t. So here t comes out 5 into 6 10 to the power minus 7 upon this is 0.5. So it will be actually 6 into 10 to the power minus 6 only. That is 6 micron. Actually 6 micrometer. The answers are given there 6 mu, 7 mu. Actually mu means micron, 10 to the power minus. Actually itne meter. 1 mu itne meter. असल में म्यू तो 10 टू पावर माइनस 6 होता है. यहाँ लैंग्वेज में थोड़ा प्रॉब्लम है बुक में. तो दिस इज द आंसर हियर. आई होप यू हैव गॉट माय पॉइंट. नाउ नेक्स्ट क्वेश्चन हियर. आई होप यू हैव गॉट माय पॉइंट. नाउ नेक्स्ट क्वेश्चन हियर. Young double slit experiments. Young's double slit experiment, the same diagram, please keep in mind, S1, S2. Young double slit experiment is first performed in air and then in medium other than air. It is found that eighth bright fringe in the medium lies where fifth dark fringe in air. The reference of medium is nearly. So this question has been asked in NEET 2017. Actually, when we perform this experiment in air, so we get a bright fringe. Now when we dip the whole application in a medium, then he says that 8 bright fringe of the medium lies where 5th dark fringe, in air. 5th dark fringe in air. So in air, wavelength suppose is lambda, and wavelength in medium b lambda dash. So when we use in lambda, so they say that 8th bright fringe. So position of 8th bright fringe. Eighth bright fringe in medium. Equal to the position of 5th dark fringe. In air. So when we change the medium, only wavelength changes, and position of mth dark, dark, चलो जो भी है, equal to m minus 1 into lambda b upon 2d, while position of nth bright वो n lambda d upon d होता है. तो 8 bright fringe in medium wavelength lambda dash, तो 8 into lambda dash d upon small d is equal to 5th position of, so put m equal to 5, 2 into 5 minus 1 into lambda d upon d. Lambda d upon d cancelled. So you get here 8 lambda dash is equal to, sorry यहाँ 2d भी होगा, sorry 2 छूट गया मुझसे, तो it is 9/2 lambda, and therefore eight into 2 lambda dash equal to 9 lambda, और lambda upon lambda dash is equal to 16 upon 9, and we know lambda upon lambda dash is index n. What is n here? Reference index. N is equal to 16 by 9. 9 1 जा 9, 7, 9 is 63, फिर 7, 7, तो nearly 1.78. You can write. This is the answer here. Choices are 1.25, 1.59, 1.69, 1.78. So I hope we have got my point. Actually, a very small effort may change your life, but extra effort is necessary to complete the competitive exam. If you want to rise your level, you have to work hard. Then there is one question here. Yes, good question. 17th. I think you might have learnt de Broglie wavelength of electron, matter wave, moving particle has wave character, and the wave associated lambda is equal to h upon p means mv. De Broglie wave lambda is equal to. So here question is like this. A beam of electron is used in Young double slit experiment. If the speed of electron is increased, then fringe width will increase, decrease, remain same. Fringes will not be seen. But when there is wave character, तो fringes तो होगी. अगर मैं यहाँ 100 स्लिट एस हमारी है and it produce electron beam, तो these two slits are illuminated, तो fringes तो obtain होंगी. And width of fringe is lambda d upon d. You are increasing the speed, so wavelength will be decreasing. Mass of the electron supposed to be constant here, although it also increase with the speed. Mass of electron also increase with the increase of speed. So wavelength as a whole decreases, and as wavelength decreases, fringe width will decrease. Please listen me carefully. Wavelength, nature of moving particle was told by de Broglie. And de Broglie wavelength called matter wave. Electrons have wave character, moving electron, moving particle. And now we have a practical application. There is one device called electron microscope. Have you heard electron microscope? When I ask student why it is so called, to their answer is that we can see electron. No, we can't see electron. Electron microscope is named, it is named electron microscope because instead of light we use electron beam. And I think the students who are preparing for competitive exam, lambda for electron beam तो यही है. How to produce motion electron? We accelerate electron, and that is 12.2 upon under root 3 angstrom में होता है. Wavelength of visible light varying from 4000 angstrom to 6000 angstrom. So, and wavelength of electron beam when accelerated to 100 volt only 1.22 angstrom, or with 10,000, so it will be 0.12, very small. There is a term resolving power. Smaller the resolving power, smaller the wavelength, larger the resolving power. So once there was a de Broglie wave application, practical application in electron microscope. So electron microscope used because it can resolve the image or distance between two objects nearly 10,000 times that of optical microscope. My colleague said when this question was there, okay, which has greater resolving power, electron microscope or optical microscope? They cried electron microscope is not in syllabus. Electron microscope is practical application of de Broglie wave. Resolving power is taught. तो ये सब है ना ब्लेम गेम होता है, अवॉइड दिस. So I hope you have got this question. When we use electron beam to obtain fringes and we increase speed, so fringes will decrease. Now there is one question here. 17th हो गया. Yes. A mixture of light consists of wavelength 590 nanometer. 1 lambda is suppose lambda 1, 580 nanometer. 590 sorry. 590 nanometer. A mixture of light consisting of wavelength 5 nanometer and an unknown wavelength. Lambda 2 is not known. In double slit experiment and gives rise to two overlapping interference fringes on the screen. The central maximum of both light coincide. Further, it is observed that third bright fringe of known light coincide with fourth bright fringe of unknown light. By central bright fringe coincide. Then as you on screen, they say that further it is observed that third bright fringe of known wavelength, third fringe, or coincide with fourth fringe, fourth bright fringe. So naturally this way, because position of a bright fringe on the screen, xn equal to n lambda d upon d. Third fringe of this and fourth of this coincide. It means this wavelength is smaller. So we can write 4 into lambda dash d upon d is equal to 3 lambda d upon d. Cancelled. So lambda dash equal to 3 by 4 into lambda. So 3 by 4 lambda is 590 nanometer. So then it is 3, 0, 3, 9 are 27, 2, 15, 17 upon 4. 4, 4 are 16, 4, 3 are 12. है तो कुछ आगे आसान होगा, कुछ गलत हो गई. Sorry. 3, 0, 0, 3, 3, 9, 27, 2. Or then 3, 15, 17. So 1770 upon 4. 4, 4 are 16. 1, 4, 4 are 16. 1, 4, 2 are 10.5. Yes, 442 nanometer. I hope I should stop now because people have come with firecrackers. This nonsense, nuisance is being created by people. There is no season of Diwali is far away, but okay, we will meet